welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Will Sweet.
Thanks, William. And thank you everyone for joining what's going to be a very quick presentation on concentration. So why is concentration important? And we're going to be spending the rest of the time talking about finding the sweet spot. So finding that perfect concentration or that perfect concentration range for a new cleaning process, or if you're looking at improving your cleaning process now. So to start off this, we're going to be talking about cleaning variables. So when in a cleaning process, when you're setting up a new cleaning process, there are only so many things that you can really change. You can move up or move down in order to improve cleanliness or improve the process altogether. And for this, we use an acronym called TEST, T-E-S-T, the forces of cleaning. These are, the things that you can mess with, the things you can move up and down to improve a cleaning process. And TEST stands for time, energy, solvency, and temperature. Briefly, what these are, again, you can increase time to increase cleanliness in general. Again, there's always the rule of diminishing returns, but in general, increasing time gives you more time to clean parts. Energy, this is referring to what type of machine or what type of washer you have, what type of impingement, whether it's spray, immersion, ultrasonics. A lot of times with this one, you're pigeonholed. So either you're walking into an existing process and you have a machine that you have to work with. So you're pigeonholed into that. Or you're getting a new machine, but still at the same time, once you make that decision, that's the type of energy that you have. There's no changing that after that. Solvency, how well the soil is solubilized by the cleaner. That's referring to the chemistry cleaner. So that's choice and strength. So that means concentration, strength, how much chemistry we have in there, and also the actual chemical product choice. That's all being referred to in solvency. And finally, temperature, just like time in general, if you increase temperature, you increase cleanliness. But if you increase it too much, again, we're dealing primarily with water-based products. You're going to run into boiling and things like that. So there's definitely diminishing returns. But again, in general, the hotter it is, the easier it is to clean. And we're going to be spending the rest of this presentation on the S in T.E.S.T, and that is solvency, and in particular the concentration of the chemical choice that you go with. Concentration. So what this is, very simply, is just the ratio of water to chemistry, at least for the sake of this presentation. Water is typically the larger portion of this in parts washing. Ideally, a stable concentration over the length of the bath. So you're looking at an acceptable range. So setting up something, say, your part comes clean consistently at 5% concentration. So maybe set up an acceptable range of 4 to 6. So anytime that the concentration is between 4 and 6%, you know that you're in the acceptable range and you don't have to adjust the concentration at all. And when you do this, you're able to eliminate potential variables. So if something does go wrong in the cleaning process, you can rule out the variable of concentration. You know that's not the issue. But we'll get into several of those as we keep going through this presentation. With all this said, it's also worth mentioning something about monitoring the chemistry. So using something to check the concentration, whether it's titration, whether it's conductivity. There's a few different methods out there to do that, but just so that you can always find out what your concentration is at any given time. And then dosing. So once you know what that is, dosing it with more chemistry to make sure that it is staying within that acceptable range. Improper concentration can lead to several different things, and that's what we're going to be talking about through the rest of the presentation. When your concentration is out of whack, it can lead to cleaning decline. It can lead to inadequate protection, short bath life, and process malfunctions. Cleaning decline in particular. If you think about it this way, would you wash your car with 1 drop of Dawn dish soap? And then on the opposite, would you clean your dinner fork with a flamethrower? It's important because you always want to keep your specific cleaning specification in mind. Essentially, to get your fork ready to be used again to eat, you don't need to burn off anything. You don't need to use a flamethrower and make sure it is that pristine clean and free of any other residue or potentially metal in that case. But that's kind of what we're dealing with the concentration. Too little chemistry may prevent you from reaching that specification, which is why you want to make sure you have enough chemistry in there, and in some circles, soap, detergent, making sure that you have enough in there to get the job done that water by itself would not do. And in the other side of things, too much chemistry could leave undesired residue. So a lot of these chemistries out there have different chemical makeup. So if you're running really high concentrations, upwards of 50%, it could leave some soap residue on the part, which is also just introducing a new variable that would not allow you to meet your specification. Also, people can become too clean. Depending on what your specification is, a lot of people out there still need to have small amounts of lubricity left on parts and things like that. And if you're cleaning too much because your concentration is too high, they may not have that lubricity there. So that's why it's really important to find the sweet spot to make sure that you're getting the part as clean as you need it to be, because clean means something different to everybody. Something else that can go wrong with improper concentration management is inadequate protection. This comes into play in particular with steel parts, because steel rusts, or at least mild steel and cast iron, things like that. Steel parts and aqueous processes need rust protection left on the part after it has been cleaned. So the most important question to ask is, how long do you need it protected for? If you only need it protected for a couple of days, that opens a lot of things up. You don't have to use, in a lot of cases, you don't have to use a dedicated rust preventative product. Just make sure that you have enough concentration and chemistry in the bath so that there is some of the product left back on the part, so you can get that 1 or 2 days. But if you need upwards of 60, 90 days, you're most likely going to need a dedicated, potentially cleaning / corrosion protecting part, which you can find from your chemical provider. And typically those leave a dry film behind, which will give you long-term protection for those parts. Still, other metals like aluminum and the other yellow metals may also need corrosion protection. It's usually not as detrimental as rust is for steel, but similar vein, different concentrations of those chemistries can have different timelines as well. So you need to know how long your part needs to be protected for, and making sure that you're getting enough chemistry in the bath so that it can protect the parts after cleaning. Short bath life is also something that can happen if you don't have enough chemistry in the bath. In many cases, especially when chemicals are involved, oils will be split to the top of the bath with enough concentration. So again, you're removing oils off the part, but those oils that you're removing are going into the bath afterwards. And with most of these and these aqueous processes, it is alkaline based, so higher on the pH scale products. And that is going to allow, once the soil or the oil is put into the bath, it's going to rise and split to the top of the bath. And there it can be removed. That's actually, all of that's by design. So whether you have a belt skimmer or a coalescer, some kind of oil removal device, that's why you actually want that to happen. So then the oil from the parts will eventually be removed from the bath with one of those devices, and keep your bath clean and keep it cleaning your parts longer. So again, the alkaline nature of many of these cleaning products is what is doing the heavy lifting when it comes to cleaning and splitting oil. So less chemistry equals less alkalinity to be eaten up. So in general, it's not perfectly linear, but yes, if the less chemistry you have in there, the less alkalinity that the oil has to eat up, and then you will have to change your bath out more frequently. And finally, process malfunctions can happen if you don't have proper concentrations, in particular foaming. X amount of defoamer is required to see results in baths, especially large baths. So if you don't have enough chemistry in the bath, you also do not have enough defoamer in the bath. So if you're cleaning a soil that is in particularly foamy, you're going to want to make sure that you have enough product in there so that the foam can be killed by the defoamers in the product. Also, too much concentration can be a bad thing when it comes to cross-contamination. If you have multiple tanks, you have a wash and a rinse tank, If you have too much chemistry in the wash, more of that product may bleed over into the second rinse tank, whether that's a tank-to-tank immersion process when you're dipping parts in and then you're bringing them back out and then dipping them into the second tank. Whatever water or chemistry or soap that you have on that part that isn't dripped before it is transferred to the next tank is going to be put into the second tank. So if you need a clean rinse with only water in it, you want to avoid cross-contamination as much as possible. And then, of course, there's special application specifications. When it comes to passivating stainless steel, there are very strict parameters that you have to use for different products, and that includes concentration. There's a specific ASTM concentration range that you need to fall within when passivating stainless steel if you want to meet the spec. Same for phosphating. That's prepping the part for paint. You want to make sure you have enough chemistry in there so that you're able to effectively phosphate for the next phase of the process. And rust removal is also worth mentioning. Typically done with an acid. Actually, all three of these special applications are typically done with an acid-based product, lower pH scale. With rust removal, everyone's process is different. It depends on how much rust you have, how long you've had rust, where it's spread to, but typically it takes a very high concentration to adequately remove all of the rust. And finally, the conclusion, finding the sweet spot is very important when setting up a new cleaning process. When you're able to find that sweet spot and find the perfect concentration or the perfect concentration range for your new cleaning process, you're able to avoid cleaning decline like we talked about. You're able to avoid inadequate protection. You're able to avoid short bath life and also process malfunctions. So this is just like the other four forces of cleaning that we talked about at the very beginning. If you're making sure that your concentration is under control, there's a lot of variables that you don't have to worry about. So if something goes wrong, you're able to eliminate a lot of different things that you're going to have to look at if you are within your acceptable range of concentration. And moving on to the frequently asked questions on this topic, how should I check my concentration? And there's I alluded to this earlier, but there's a few different ways that you can do this. One way is with titration or alkaline titration, and simply what that is counting drops. You're counting the amount of drops that it takes for your sample to change color, and you're able to correlate that amount of drops with a % concentration. That is tried and true. That is always going to be correct. There are other ways that are quicker, maybe a little less cumbersome. Titration really isn't that difficult. It does take time. It's a small science project where you're literally counting drops. But you can also do conductivity, assuming that the soils or oils that you are removing that will be into the bath are not conductive themselves. If you're able to verify that, then you can get a conductivity meter and stick the probe in a bath sample. It will give you a millisiemens reading, and that directly correlates to a % concentration. We use a refractometer to measure our coolant concentrations. Can we not use one of those to monitor our wash baths? I get this question a lot. There's a lot of refractometers out there with people that have coolants in their building. The short answer is no. You cannot use a refractometer, at least with any of our products or really any other product that I've run into. And that is because refractometers are not able to tell the difference between oil and chemistry. It sees it as the same. So if you think about it that way, if you have a very dirty bath or just a regularly dirty bath, it's going to mistakenly read whatever oil is in that bath as chemistry and give you an artificially high reading. So in that sense, it is just going to be incorrect unless it is a very clean bath, very fresh bath probably. What if we find out that we overfilled our fresh bath? How do we bring concentration back down to where it should be? Very good question. Overfilling is a little harder to deal with than underfilling. But what you're going to have to do is you're going to have to dump some of that bath at least to make sure that you're exactly correct. you would most likely need to dump the entire thing and start new. And that way you can fill up volumetrically. So if you have a 10-gallon tank and you need 10% concentration, you know it's going to take 1 gallon to get you to 10%. Just like titration, that's tried and true. Volumetrically, that is. But especially with larger washers, that's an expensive endeavor. So I would recommend dumping a fixed portion, whether that's maybe half. So in that 10-gallon tank, say you filled 20%. So that means you put 2 gallons in. I would dump half of it. That means there's 1 gallon left over, and then you can simply just add water. You're able to do math a little bit easier if you have a fixed amount that you're dumping. Finally, when would it make sense to use titration over conductivity? I alluded to this a little bit in the first question, but it would make the most sense if you think that your soils may be conductive in themselves, or you're just not sure and don't have a good way of checking. Because again, titration is tried and true. It is always going to be correct. And that is when I would recommend using titration over conductivity. If you're not able to verify that the soils you're removing into the bath are not conductive. And I believe that is all the time I have for you guys today.
Thanks, Will. And thank you guys for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in this session, please contact your local KYZEN regional manager or send an email to tech@KYZEN.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.